Hello everyone, welcome to Digital Electronics lecture series. This is lecture number 15. We start with NAND and NOR as universal gate. So NAND and NOR, these two gates, they are called as universal gate because we can construct any other gate using either NAND gate only or only NOR gates. So let us see first how do we use NAND as universal. Then we can see NOR as universal. So NAND as universal first of all. Now before starting with NAND as universal, how the NAND gate works, we have this, suppose 2 input NAND gate. This is a 2 input NAND gate. So if this is A, this is B, output is A and B the whole bar. Okay. Now first of all we see NAND as NOT. First is NAND as NOT. So I'll just draw the diagram of NAND as NOT. So this is a NAND gate. So for the working of NAND as NOT, we short the input, that is connect both the inputs together and give this a single input. Suppose this is A. So what is Y then? What is the output? So if input is A, B, we have A and B the whole bar. So here both the inputs are A. Both the inputs are A. So output will be Y is A and A the whole bar. And using Boolean algebra, A dot A and A is A. So this is A bar. So input is A, output is A bar. So this becomes a NOT gate. So this is how NAND can be used as a NOT. So what we conclude is a NAND gate whose input are shorted works as a NOT gate. So a NOT gate. Then next what we study is NAND as AND. So next is NAND as AND. NAND as AND. Now what we do in this case is we take two NAND gates. Now how do we take those NAND gates is, first of all, this NAND gate, first input NAND gate, this is one NAND gate, then this output goes to another NAND gate. So here we have another NAND gate and here we get the output. Now let us analyze this. Suppose input is 2, A and B are the inputs. So when A and B are the inputs, this is a NAND gate. We know this NAND gate output is A and B the whole bar. So this is A and B the whole bar. Now here previously what we saw here is NAND gate whose input are short circuit or shorted, it acts as a NOT gate. So this particular gate is acting as a NOT gate. So what we have, I will just write it here. So Y output is A dot B bar, and because of this particular gate NOT, again one more, okay, again NOT. So complement of complement is same variable itself, A y, okay. So double complement is the same thing what we get. So double complement of A is A itself. So same way A dot B double bar is A dot B, A and B. So this is Y is A and B. So input is A B, output is A and B. So this becomes an AND gate. So this is how NAND works as a AND. Now let us see how NAND works as a OR gate. So NAND as OR. NAND as OR. So for NAND as OR, we use 3 gates. How we use it? So here this is the first gate, which is whose input are shorted. Then second gate, same way, inputs are shorted. Then this goes to third NAND gate. Now let us do the analysis of this. So suppose if this is A, this is B. Now we know NAND gate whose input are shorted works as a NOT gate, so this becomes A bar and this becomes B bar. And because this is a NAND gate, so if input is AB, output is, as we have seen here, if input is A, two inputs A, B, then we have A and B the whole bar, but here inputs are A bar and another input is B bar. So I will just write it here what we will get. So Y is A bar B bar the whole bar, because inputs are A bar B bar. Now we apply De Morgan's law here. So De Morgan's law says the break the line and change the sign. So this is A double bar this dot, this becomes OR. A double bar is A and B double bar is B. So this is what the output we get. So output is Y equal to A or B. So input is A, B, output is Y equal to A or B. So this becomes OR gate. This is how it works as a OR gate. Now next, how it works as a NOR gate. I will write it here only. No need to draw another circuit. So here, this up to here it is working as a OR gate. Now how do we make up it as a NOR gate? So for that purpose, you can even guess it, because you just want a NOT gate after this. So how to draw this NOT gate? So this is given to another NAND gate whose inputs are shorted. So this is working as this particular gate will work as a NOT gate, and because of which what output we get here is Y is A or B the whole bar. So this is working as a NOT gate. So if input is A, output becomes A bar. So input is A or B, output becomes A or B the whole bar. So this is how NAND works as a universal gate. So NAND here in the first diagram we saw NAND as NOT, NAND as AND, then NAND as OR, and here NAND as NOR. Now next is NOR as universal. So NOR as universal, we will use NOR as NOT, AND, OR and NAND. So before starting with that, let us see how a NOR gate works. So this is a NOR gate. So input is A. If input is, we have to input A, B. So output is A or B the whole bar. So this is how a NOR gate works. Now first we see how NOR works as a NOT gate. So NOR is NOT. So we take a NOR gate. This is a NOR gate. Input, two inputs. So we short the inputs and take it as suppose A. So let us see what output we get because of this. So if input is A, B, output is A or B the whole bar. So input is A, so this both the inputs becomes A and A. So Y, let us analyze the output. So Y would be, output would be A or A the whole bar, but we know A or A is A, so what we get is A and bar. So therefore output is Y equal to A bar. So input is A, output is A bar, so it works as a NOT gate. Okay, so if we short the input of a NOR gate, it works as a NOT gate. Now let us see first, then second is NOR as OR. NOR as OR. So for NOR as OR, we take two gates. So this is the first one. Then this is given to the second gate, NOR gate, which is shorted input. Sorry. So this is, so input is A, B. So here because it is a NOR gate, so we have A or B the whole bar. Okay, simple. Then this particular gate is acting as a NOT gate. So if we analyze what output we will get is A or B, whole bar is already there, then this NOT will introduce one more bar to complement again. So double complement is what we get is A or B. So what output Y is A or B. So here what we see, input is AB, output is A or B. So it is working as a OR gate. Now next is NOR as OR. So NOR as AND. Next is NOR as AND. So here how we analyze this, how we draw this is, first we take a NOR gate, then we take another NOR gate, then we take here one more NOR gate, so this input is shorted, this input is also shorted, so this is suppose A and this is suppose B. So here we have seen a shorted NOR gate works as a NOT gate, so this becomes A bar, this becomes B bar. Now what about the output? Let us analyze the output. So if we analyze the output, what we have is Y is, the input is A bar B bar, so output is A bar or B bar the whole bar. Now we can apply De Morgan's law, so break the line and change the sign. So this is A double bar or and B double bar. A double bar is A, B double bar is B. So output is A and B. So Y is A and B. So here what we see is input is AB, output is A and B. So it is working as a AND gate. Now finally, how it works as a NAND gate. So we can just make corrections here. So next is output as a NAND gate. Okay, so I will just rub it out, this one I don't need. So here I draw one more NAND gate after this, which is of course shorted. So here input is shorted, this one, so now input is A and B and this is working as a NOT gate. So what we have, simple, Y is actually A and B the whole bar. Okay, so this is input is AB, output is A and B the whole bar. So this is working as a NAND gate. So that's it, how we show that is our NOR is NOT, NOR is OR, NOR is AND, and of course NOR is NAND here. So up to here it is acting as AND, and here then NAND. Okay, so now we'll study input bubbled logic. So input bubbled logic is used to study the working of many logic circuit. It becomes easier to understand the working of a logic circuit by considering the input bubbled logic. So first of all, we study input bubbled AND gate. The first is input bubbled AND gate. So what is input bubbled AND gate? Normally we have, this is the AND gate, this is the AND gate. So this is the AND gate, a normal AND gate. But now what's the meaning of input bubbled is, what we are doing, we are just introducing a bubble here, that is a NOT gate at the input. So here this is a, and here we have the gate. So this is input bubbled, means this is a bubble, means we are placing a NOT gate at the inputs. Now how will it work? So we have two inputs, so we have 4 combination, A, B and the output. So let us see what output we'll get for input bubbled AND gate. So input is 0 0 0 1 1 0 1 1. Now remember that whatever input we are giving, it is inverted because there is a NOT gate. So input 0 means actually input is 1, Okay, whatever input we are giving here, suppose I am giving 0 here, so this 0, because of this particular bubble, it becomes 1. And if I am giving 0 here, because of this particular bubble, it becomes 1. And if I am giving 1 input, if I am giving this 1, then what will happen? This particular input will become 0. Okay, so the first input 0 0, it is actually 1 1. So a 0 0 means 0 0 input means here we are giving actually 1 1 input. Okay, so let us see what happens. So when input is 0 0, so actually the input is 1 1, and input of AND gate is 1 1, output becomes 1. Next input is 0 1, so 0 1, so input is 1. Here this input will make this particular actual input as 0, so any input is 0, output becomes 0. Again for this also 1 0, so because of this particular, suppose 1 is here and 0 is here, so this one will make input as one of the input as 0, so this is also 0. And finally 1 1, 1 1 is both will become 0 and output is 0. So this is the output, this is the output of a input bubbled AND gate. So what is our conclusion? This actually, this truth table, okay, this truth table for where 0 0 is 1, 0 1 is 0, 1 0 is 0 and 1 1 is 1, this is the truth table. This particular truth table is of a NOR gate. Okay, so what we conclude here, the important thing is our conclusion. What is our conclusion? That input bubbled AND gate works as a NOR gate. Okay, so it is equivalent to a NOR gate. Okay, this is our conclusion, that input bubbled AND gate works as a NOR gate because this is the output of a NOR gate. So next is input bubbled OR gate. So this is OR gate and we have bubbled the input. Okay, so let us see what happens with the input 0 0 input. So 0 input means it actually 1 input. 0 input actually, because of bubble, it becomes 1. So input is 1 1, output is 1. Okay, then again 0 1, so input is 1 0, and OR gate, for OR gate, any input is 1, output becomes 1. So this is also 1, and even this 1 0, because this 0 becomes 1 output, this 0 becomes actually 1 input. Okay, and 1 input means output is 1. Then finally when both the inputs are 1 1, so both the inputs in actual case they become 0 0, so 0 0 is output is 0. So this is the truth table what we get of the input bubbled OR gate. Now if we critically observe this, if you observe this actually output is this particular output is what we get for a NAND gate. Okay, so what is our conclusion is that input bubbled OR gate works as a NAND gate. This is our conclusion. Next is input bubbled NOR gate. So this is an input bubbled NOR gate and these are the inputs. So first 0 0 input. So 0 0 input will make the actual inputs as 1 1, and for a NOR gate, even when a single input becomes 1, output becomes 0. Okay, so here because we have two inputs 0 0, which will become actual inputs will become 1 1, so this output is 0. Okay, so this output is 0, I'm just making it 0. Then the second 0 1, so because of this 0, one of the input will become 1, so this is again 0. Here also because of this 0, the input will become 1, and one input at NOR gate makes the output as 0. Then the last case, both inputs are 1 1, so subsequently it will make both the inputs as 0 0, and 0 0 input at NOR makes output as 1. So this particular truth table what we got, that 0 0 is 0, 0 1 is 1 0, 1 0 is 0, 1 1 is 1. So this is the truth table of a AND gate. So what we conclude that input bubbled, so what we conclude is input bubbled NOR gate works as a AND gate. works as a AND gate. This is our conclusion. Now finally we have input bubbled NAND gate. So this is the input bubbled NAND gate. So these are the input 0 0. So this 0 0 will make actual input as 1 1. So output of NAND gate is high when at least one input is low. So if a single input is low, output becomes high. So in the first case, both the inputs are 0 0. So the actual inputs will be 1 1, and because of which this will become 0. Then because of this one input, one of the inputs will become 0. Okay, so output will become 1. Here also 1 0. So because of this particular one of the inputs, actual inputs, will become 0, and because of which output will become 1. In the final case, both inputs are 1 1. So both inputs will become 0 0, and because of which output will become 1. So this particular output 0 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 is 1 is for a OR gate. So what we conclude is that input bubbled NAND gate works as a OR gate. Okay. Now let us summarize. Input bubbled AND gate, it works as a NOR gate. Input bubbled OR gate works as a NAND gate. Input bubbled NAND gate works as a OR, and input bubbled NOR gate works as a AND gate. So that's all for this session. Thanks for watching.